next is called synthetic division, and this is a shortcut to doing that. It's pretty much doing that same process, but it's doing it in a very different way. So what they do first of all is they look at whatever their polynomial is. Notice that these are in descending order, 3, 2, 1, and then no exponent. Okay, we need to have that. We need to have every variable there. And I'll show you what to do if they don't have that variable. I'll show you that a little bit later. The next thing is this needs to be x minus r. That means that the coefficient of x needs to be 1. X needs to be by itself when we divide. If it's not, I'll show you what to do later. This needs to be a negative sign. So if I had something like x plus 2, I would want to rewrite that as x minus a negative 2 so that whatever my r is would correspond to whatever's in that negative there. So in this case, if it was x plus 2, my r would be a negative 2. But this one is not. This one is dealing with negative r. So what they're going to do is they're going to write out this thing. They're going to write a bar here. Make sure you get this little bar here. That is important. We'll get to that. And a little space here to separate this. Our r goes in this place here. So since this was a minus 2, we put a positive 2 here. For the other numbers, now again, check 3, 2, 1, and then no x. It has to be in that order, and every term has to be there. But I'm only going to take the coefficients, the 5, the negative 13, the positive 10, the negative 8, and I'm going to write those out in order over here. Our first step then is to just bring this one down. Just bring down the 5. That's it. And now is when we start using the 2. Our steps are going to be this. We're always going to do two things. We're going to multiply this number times whatever's here. So notice they follow that chain. 2 times 5 gave them 10. And then we add them by going down. So that negative 13 plus 10 gave them a negative 3. Okay, so multiply and then add. Then you do the same thing. You keep repeating those same steps with each number. So 2 times negative 3 gives me 6. I add them. 10 minus 6 gives them 4. Okay, and we keep doing that over and over again until we've covered every term there. 2 times 4 is 8. We add the negative 8, and 8 gives us 0. Now we look at how to analyze this. This last break, the reason that we separated this is this will always be our remainder. Now in this case, we don't have a remainder. What we do with the rest of the terms here then is that these are now our terms of x. And we started in this one with x cubed, and we're basically dividing by x, so our first term should be an x squared. So that's why we start with a 5x squared here, minus 3x plus 4. Those go in descending order, and they will always go in descending order. Now another way to do this, if you don't remember what this first term is, just remember that the last one here before the bar is going to be no x, and then they can grow from there, then x, and then growing from there, x squared. But basically, since we started with x cubed, we divided by an x, we should start with an x squared, and then we descend. So that's synthetic division. So let's do another problem like that. First of all, let's check this. Check our terms going x3, 2, 1, 0. So that's good. Those are in the order that we want. I'm going to write their coefficients. I had a 2, a 3, a negative 4, and a 15. Over here, this was supposed to be our minus 4. And so if we look at our r in this one, it should be the negative 3. Okay, because I would want a negative 3 here to get a plus. And so over here, I'm going to use a negative 3. We get a bar here. Remember, the last term is going to correspond with our remainder, so we want to separate that. Okay, now our first step, just bring down the 2, but now we start doing our 2 steps. We multiply, so negative 6, negative 3 times 2 is negative 6. And then we add that column, which gives me a negative 3. I repeat, negative 3 gives me a positive 9 when I multiply. I add the row then to get 5. negative 3 times 5, we multiply, negative 15, and then we add. Again, I get a remainder of 0. And so when I write my answer here, all this, when we divide, we get a 2, a negative 3, and a 5. We need to think about our x's. Remember that we start with no x, x squared. We just work backwards from there. That should be a plus. I can check it. I had x squared divided by x, and so that should have given me an x squared. I could also possibly check this by, I could probably factor this by x plus 3, or I could just, to get this, I can multiply it by x plus 3, and if I did it right, it should give me that. Okay, now one other thing, I said that this has to be x minus r. But in this case, we have something else in front of x. We have a 2 there. We can't do that. So this is what we're going to do when that happens. We're going to divide everything by 2. And by doing that, we're going to get an x on the bottom. Now, we will also get a fraction there of 1/2. On top, we also have to divide everything, 8 divided by 2, 4 divided by 2. Here we're going to get another 1/2, and then 2. So that when we set up the synthetic division, we're going to get this. So I would bring down the 4. I multiply, which would give me a negative 2. I add again. I multiply, which will give me positive 1. Add again. We multiply, we get positive 1/2. We add those, that gives me 1. Multiply, I get negative 1/2 again. Now I'm going to get a remainder here. And that's going to be 3/2. So when I write my answer, I can start with this. Now, maybe working backwards, it's going to be no x, this will be x, this will be my x squared and x cubed. So I'm going to have 4x cubed minus 2x squared minus x plus 1. But then I need to also add my remainder on here. And what we're going to do with our remainder is we need to divide it by what we were multiplying by. So it's going to be like whatever my remainder is divided by x plus 1/2. Now this one really I could also multiply like this, 1 over x plus 1/2, because we're dividing there, which would give me 3 over 2x plus 1. Notice we end up again with the 2x plus 1 in this, and so I can rewrite this here, 3 over 2x plus 1. It doesn't divide evenly, but we have an answer that if we multiply all of that by 2x plus 1, we would get that. Okay.